Today we're going to talk about the topic of clustering. Clustering means finding some kind of groups or segments of, let's say, customers. So an example would be that if a retailer tracks customer purchases, he wants to automatically detect customers with similar buying patterns. So people's demographics go into that, but also their buying kind of history, and people with similar age and income may have still as different styles of dress. And what we want to do is we want to kind of discover those fashion islands automatically that will influence our marketing strategy. Or to bring a few more examples, in a marketing context, we could also be talking, besides those customers and their demographic information and the buying patterns, we could be talking about the stores. We could take into account the store's location, the income of the people who are at that location, the education level of the people at that location as well. Now, with data analysis, with SAP predictive analysis, data analysis, there are broadly the methods that we're using can be told to be as either supervised or unsupervised data analysis methods. Let's bring some example. So right now, in the third learning module, we're going to look at something that's a supervised data analysis method. Its name is decision trees, and this means that we're going to classify objects as let's say, our customers as such that are going to buy our product or not, or a customer who's going to churn from our company or not, or a customer who's going to be prone to having payment issues or not. So this process itself is called classification, which means that we have to decide whether something is going to happen one way or the other. But it's a supervised technique because we're going to kind of take the whole bunch of data and create a analysis model, with which when we create it, we know the right answer in advance. So we know which customers really did churn or didn't from our historical data, which did buy or didn't from our historical data. We just have to set this decision tree model in such a way that it will correctly discern the customers into one or another class. Now, what we're doing today is the other way around. It's unsupervised learning. So clustering and finding groups and segments goes under that. And once again, it's what are the customer groups, it's what are the store groups, the questions we're asking an answer to. Now, with that, we actually don't know the right answer. We might not even know how many groups we want to attain. So it's not like we will tell the predictive analysis tool in advance that we want to find out those, in the case of telecommunications, those retired people, those students, those family heads. It's going to emerge naturally from the data. So in that case, we feed all the data in there, and it's going to take those groups out for us, those customer groups, and it's an unsupervised learning method. Now, why are we talking about the distinction between supervised and unsupervised methods? Well, as we saw in association rules, we're firmly in this side of the IT business domain boundary. So we're in the business domain and solving business problems. But if we want to make those algorithms work, we still need to, it's essential to get the right answers out. It's essential to set those algorithms to work in a correct way. So we need to have some kind of a general understanding of how they work in order to be able to set those percentages, those numbers, those stopping criteria that the algorithm has. Otherwise, the algorithm is going to be a black box for us, but the only thing is that we need to know kind of these buttons and toggles on that black box in order to make it work as we wish it would. We're going to be considering two methods of clustering, and the first one is hierarchical clustering. So we'll see how that works in SAP data analysis tools. And the second one is k-means clustering. Let's see how that works. So first of all, in here we have a set of data, 5 points of data, A, B, C, D, and D. And what we want to see is which one of them are the closest to each other. And it turns out that A and B are. So we join them into kind of one cluster and put their midpoint somewhere here. And now we just keep on doing the same thing. So we want to see what's the next closest pair of points now. And it turns out that this center point of A and B, this cluster, is very close to C. So we kind of join those into one cluster. And now we have this center point somewhere here. Now the next closest thing that we are going to find will be that D and E are quite close to each other. So these are joined into a cluster. And then lastly, we basically only have the center point of D and E and the center point of A and B and C, and then we'll join them into a cluster. So this is hierarchical clustering, and what's a good side of it is that you don't have to tell the number of clusters in advance, and you will be able to kind of choose the number of clusters, and you'll get the results as we see in a second. Another thing is that we talked here about the closeness, how close A and B are to each other. So we will be seeing more of that on the Learning Module 3 on recommender systems. But let's just say that right now we're talking about A and B being close to each other, like in a very intuitive sense. So if two customers are like very similar, they're close to each other. More on that on recommender systems. Okay, so we got those clusters formed, and now how to really make sense of any of this. So on the next slide, we have the process depicted in a bit different way. So you see that A and B were clustered into one cluster at first. So here we're progressing in this direction, and here is A and B joined. A, B, and then C were joined next. Then D and E were joined, and then everything was joined. So this is a result of the hierarchical clustering. It's essentially called a tendogram. And the way to read into it is that what if we say, we look at this picture and we say, okay, so what if I want to read out of this data two different clusters? What you do then is you put a vertical line here, and you see, okay, A, B, and C are one cluster, and D and E are another cluster. If we want to say, okay, but the data more looks more like 3 clusters, then we just put the dividing line here, and we get the result that A and B are one cluster, C is totally separate, and then D and E are their own cluster in turn. So that's kind of a good side of this hierarchical tendogram clustering. The bad side, of course, is that it's very computational intensive. It takes a lot of time to compute all those things. Anyways, let's see some examples. So this is one hierarchical clustering result. We can see that there are really some intuitive things where we would like to kind of draw the boundary. So from here, for instance, a lot of rows clustered of data clustered into a similar cluster, or we would like to draw the line from here. We do have to take into account that if we draw the boundary, it has to be from one place. So we would like it to be drawn from this place, then it would cut those into two different clusters, for instance. But anyway, so as with association rules, finding information from such clusters is essentially a discovery process for the business person as well. And let me go to a very interesting marketing example here. So this data is taken from Zebo.com, and Zebo.com is a place where people go and they list what they own, and then they list what they would like to own. So you see the hierarchical clustering once again yields us some kind of a very intricate result. But if we go inside those clusters and we look, so people have, based on their similarities, have kind of tended to want together chocolate, jewelry, books, something like that. So there is also people who want lots of money, want to have a nice car, a big house. So a person who wants a motorcycle somehow is similar to a person who wants an Xbox 360 or PS3 or PS2, PlayStation 3 or PlayStation 2. So there are together clusterings of money, freedom, women, moon, friendship. So you can see really people's different aspirations. Now, if you go through all that data, you might find something interesting from the kind of a preferences of different people. So this might be one such marketing discovery process. Next to hierarchical clustering, the other way of clustering that SAP PA and SAP tools utilize is k-means clustering. Let's see how this is done. For us to be able to kind of configure all this when we run it to get the best results obtainable. Okay, so we have the same points here. The data points are A, B, C, D, and D. And now we randomly select that first of all, we want to say we want 2 clusters there. So this is something we have to select the number of clusters previously, pre-select them. And then we just, not knowing much about the data, so we don't, the algorithm doesn't have that nice drawing in front of it, it's going to put the kind of points where the clusters are. And now what it does in the next step is it's going to put all those points. So it's going to look at, let's say, this cluster, and all those points that are closer to this cluster than they would be to this cluster, like A and B. These are placed into the first cluster. And all those points which are closer to the second cluster are placed into the second cluster. So here we are. We are on the next step, and what it does, so once again, these go into the first cluster, and these go into the second cluster. Okay, and now the second step is, it's going to put now, remember the first cluster was centered here. It's going to put the center of the first cluster where its data points really tell it to be. So remember, these were the first cluster's data points. Now the center is in the middle there. And of course, the second cluster, its center, is going to be put where is the kind of middle of C, D, and D here. So this is how the clusters are moved now. Okay, and now we're through one step here, and the next step would be to do everything again, which essentially means that now the cluster is centered here, and all the points that are not in that cluster yet, like the C, but which are closer and should belong to this cluster, are moved instead to the first cluster. And the second cluster now contains these points because C just moved away. And then we once again put the centers as the next step. So now that we have in the first cluster A, B, and C, we're going to center it here. And since we have D and D in the second cluster, we're going to center it here. And this is our cluster center. So it's basically a exercise that might go on for 10 rounds or so, but finally everything is clustered into those 2 clusters, which we said in advance we want 2 clusters. And this is the essence of k-means clustering. So the only thing is, when we're going to configure k-means in SAP, we're going to say how many times it tries, how many points may change sides from one cluster to another, or to third, or to fourth, and how this process is going to be controlled. So we'll set a number of those settings, and then we'll just let it do its work. And as you see, it is unsupervised learning, because here we do say in front like how many clusters are there like too, but what we don't say is anything about which data person or customer or store must be in one or another cluster. That's something we don't say. So that's why it's unsupervised learning.